Welcome to qnawire.
So in this question, we are told that a solution, we have to calculate the pH of a solution of 0.060 molar propionic acid, potassium propionate, so Kp. I'll call it potassium propionate, Kp. And 0.085 molar propionic acid, which is, I'll call it Pa. Okay. So we know pH is pKa plus log of the potassium propionate Kp concentration divided by the propionic acid concentration Pa. So the pH is the pKa of propionic acid is negative logarithm of 1.35 times 10 to the power minus 5. Negative logarithm of 1.3 times 10 to the power minus 5, so that's 4.88 plus log of 0.060 divided by 0.085. So the pH will be equals to 4.72. V said calculate the pH of 0.075 molar triethylamine and 0.10 molar trimethyl ammonium chloride. So that is CH3, 3NHCl. Okay, so in this case, pH is equals to pKa plus log of which one is the acid and which one is the base. Okay, so in this case, this would be CH3, 3, and HCl concentration divided by CH3, okay, so the Kb for the CH3CN is 6.4 times 10 raised to the power minus 5. Okay. And we have to be careful in this because this is a base, and what is happening is that we have this CH3 3N aqueous plus H2O liquid. It can give us CH3 3N H plus OH minus, right? This is also aqueous. So the Kb will be CH3 3NH plus concentration and OH minus concentration divided by CH3 3N concentration. Okay, and that's the Kb that we have here to be 6.4 times 10 raised to the power minus 5. Okay. So we are given the concentration of this to be 0.1 right here, and concentration of this to be 0.075 right here. Okay, so if we assume that let's go back here. If we assume that the OH concentration is X, okay, so I'm gonna write out this equation again, right? So we have CH3 3N plus H2O to produce CH3 3N plus H plus OH minus. So if we are starting with 0.075 molar of this, so this is 0.075 molar. Okay, we have 0 of this initially, then the change will be minus X. It's going to produce plus X and plus X of this. Then at equilibrium, we're going to have 0.075 minus X, and that's going to plus X plus X. Therefore, Kb, which is 6.4 times 10 raised to the power minus 5 will be equals to X multiplied by X over 0.075 minus X, based on what we already established here. This divided by this, right? It's equals to this. So that's what we have here. So this is going to be X squared is equals to 6.45 times 10 to the power minus 5 multiplied by 0.075 minus X. Okay. So if we solve for X is going to be 4.875 times 10 raised power minus 5. And hex is equivalent to the concentration of OH minus, right? So then we can calculate POH, which will be negative logarithm of OH minus concentration. So POH then will be equals to negative log of 4.875 times 10 raised power minus 5, and that will be equals to 4.31. So this POH. So to get pH, we have to subtract this from 14. So this is going to be 14 minus 4.31 because pH plus POH is equals to 14. So to get pH, we have to subtract POH. We have to subtract 14. We have to subtract POH from 14. So this is going to be 9.69. So that's the pH. The C is about solution that is made by mixing 50 ml 50 ml of 0.15 molar acetic acid, that's CH3COOH, and 50 ml 0.20 molar sodium acetate. Okay, to make life easier on us, we can just determine the number of mole that 50 ml of 0.15 molar of acetic acid and 50 ml of 0.20 molar sodium acetate will be. So we need know the number of mole is equals to the concentration divided by volume. So in this case, this is going to be 50 times 0.15 divided by 1000, because the 1000 will convert this 50 ml to liters, because 0.15 molar is 0.15 mole in 1 liter. Okay, and this would be 50 times 0.20 divided by 1000. So the number of mole will be 0.0075. Number of mole of this will be 0.01 mole. So if we use the Anderson-Seebach equation, pH is equals to pKa plus log of the conjugate acid concentration and number of mole, so CH3COOH and A in this case, divided by number of mole of the ethanoic acid. Then we can find the pKa of ethanoic acid. It's 4.8. So pH would then be equals to 4.8 plus log of 0.01 divided by 0.0075. So pH will be equals to So pH will be 4.92.